First question I have up here for the tangent graph is what has to be shown on the graph when the y value is undefined. And we see it's undefined at 90 and 270. And we have to show an asymptote. So it's really important to actually draw that asymptote in. That's a really important defining feature of this graph, so you don't want to leave it out. So I'm going to draw in an asymptote at 90 and 270, and also negative 90 and negative 270. Now let's talk about some features of the tangent graph. The tangent graph repeats itself every how often? Okay, the other two graphs were 360, but notice that this graph actually has an entire section between negative 90 and 90, between 90 and 270. So this is only a distance of 180 degrees from here to here. So the tangent graph actually repeats itself every 180 degrees. It has a period of 180, which is different than that of sine and cosine. Now the domain and range are also very different. We talked about before that the tangent graph can, as it goes along the asymptotes, it gets infinitely positive and infinitely negative. So the range of tangent is from negative infinity to infinity. It's not contained like the ranges of sine and cosine. The domain is also mostly all real numbers, but we have these undefined values. So the domain is kind of weird. It's all real numbers except wherever these asymptotes are, and the asymptotes occur every 90 degrees. So let me show you kind of a cool way to describe this. We're going to say all real numbers except x is not equal to, well, I can't list all the possible asymptotes because there's an infinite number of them. They're going to occur every 180 degrees. So what I'm going to do is start with the first asymptote, which is 90, and then I'm going to say plus or minus 180n. In other words, plus or minus multiples of 180. So 90 plus 180 would give me another asymptote, plus another 180 would give me another asymptote, or minus 180 would give me an asymptote. So n just represents the number of 180s that I want to add. So if I did 90 plus 180 times 3, I would still get an asymptote. Or if I did 90 minus 180 times 2, I would get another asymptote. So n just represents the number of times to add or subtract 180. So n can be any positive or negative. It can be any number, any integer. Tangent, like sine, is an odd function because if we put opposite values in for x, we'll find opposite values for y. For example, 45, 1, negative 45, negative 1. Okay, so it is considered an odd function. Now, how do we draw the graph of cotangent? Cotangent, we're going to find the reciprocal of all the tangent values. So notice we have some values where tangent is 0, which means its reciprocal cotangent would be undefined. So that's where the asymptotes would go for the cotangent graph, at 0 and at 180 and at 360. Now, if I go the other direction on the graph, there's going to be another place at negative 180 and another place at negative 360 where tangent would equal 0, therefore cotangent would be undefined. Now, we've talked about that the reciprocal of 0 is undefined because 1 divided by 0 is undefined. But what would the reciprocal of undefined be? Well, the reciprocal of undefined would be 0 over 1, which is 0. So we can go the other direction. We can say the reciprocal of undefined is 0, which is kind of a weird thing to say, but it's mathematically correct that the reciprocal of the undefined number then is going to be 0. So that means 90, 270, negative 90, and negative 270, all the places where tangent had an asymptote are now places where cotangent equals 0. So the asymptotes and the zeros switch places. So you might want to write that down. That's just kind of a handy thing to remember. So asymptotes, and we'll call those x-intercepts, switch places in tangent and cotangent. So they switch places, but there are some points that stay the same. We know that the reciprocal of 1 is 1. So tangent of 45, cotangent of 45 is still 1. And the reciprocal of -1 is -1. So cotangent of 135 is still -1. And 225, 1. And 315, -1. So notice the pattern of the dots is going down and not up. So the curve goes the other direction for cotangent as it does for tangent, because these 2 points right here and here, they don't switch. All the 45, they stay the same. Actually, I'm going to take those off because that's kind of in the way of drawing the graph. But all the places where tangent is 45 or -45 or any of those angles that have a 45-degree reference angle, those values don't change from tangent to cotangent. So now the graph curves down like this. Okay, so remember the way the curve goes is kind of concave up, kind of like a U, sort of a half of a U shape above the x-axis, and then upside down, like, I don't know what you'd call that, below the x-axis. So be careful. It only changes. The curve only changes direction once, and that's right at the x-axis. So curve one way to the x-axis, then change and curve the other way below the x-axis. So this is what the graph looks like for cotangent. Oops, I kind of missed that one. Let's try that again. There we go. Lovely, elegant curves again.